Hello, Assalamu alaikum. My name is Ahmed Merzouk, and today I'm going to be presenting about a tool that I find really useful if you are trying to do some research. Um, so the tool is called uh, Cosmos AI, and it's by Edison, company called Edison. Yeah, Edison Scientific. So what is this? It's basically an AI scientist that allow you to find research gaps in the literature or research topics that are really interesting in your area of research. So it have been like recently introduced on November 5th. So it's basically a new tool. And what it does is that when you ask a question, let's say for example here you ask the first question, Cosmos AI is gonna try to answer the question using the knowledge cutoff that have been made to the model at that point, and then go into the internet and try to find different related articles that could be applied toward your research. So it's going to make a lot of discoveries throughout the research. So, for example, it's going to start with this question, and then it's going to move and find different related topics that are related to the question that you are interested in finding. For example, a research gap or finding a specific tool that allow you to conduct that research. And it's going to give you an output, which is a report about what are the things that are in the literature, what can you use, and it does a really good job in doing that. So here is a comparison about how this model, which is called Cosmos, compared to other models that are comparable to it. And it can read like up to 1,500 papers, and it can also read 42,000 line of codes, which is massive upgrade compared to the previous state-of-the-art model that is called Robin. The good thing about this model is that it's going to go in a sequential manner until it finds different aspects of the research that you're interested in. And it can do work that up to 6 months of work that could be done by a researcher. Um, they here, for example, give an example where the how does the model work and how the discoveries work for the science. So it's going to go ahead and try to answer based on the unpublished data where the model had already an idea about the work, and then it's gonna produce a claim, and then from that claim, it's gonna go ahead and find the different related topics. And from the topics, gonna go ahead and find more and more and more, and go like through a lot of rabbit holes until it answers the questions and find a lot of hidden stuff that you may not be able to find if you do your research by your own, and or it's gonna cost you or uh, need a lot of time from you. The model is a little bit expensive to run, so it's like $200 a run because think about it as deep research, but more for science. So it's going to go ahead and read some papers that are really useful, and then find and then give you an answer. Initially, they give you like a little bit free credits that you can use. So they estimate that this tool could reduce 6 months of research and like human labor by running a question. So what they have done is that they averaged across 7 scientists, and the work that was done was 6.14 months. That would the scientist take, and was like the first estimate that they have made. And here you see how many cycles the model run. By cycles, I think they mean tasks here. And then this is the expected time to finish the same article. And you know that it depends on much time do you spend on this project and how much interest and how much energy you put into this project. Another thing that they have done also was that, uh, uh, and I think it's here. So what they have done was, yeah, it's this one. So what they have done is that they took the model and tried to predict something that was invented by other researchers. And in this attempt, what they have done was that they tried to ensure that the model does not see the paper that the researchers found about, which because it was like a new paper. Let's pick an example, like a paper that was published in 2025, which is a new finding. And they run the model on parallel without allowing it to see the paper or the research. And then they see if the model comes up with the same research or not. They found out that the model took 4.1 months in order to find the same research, assuming like the researchers work 40 hours a week. And then they gave results. So you see here, what was the time that is allocated from an expert to generate these, which was part of reading the paper and some data analysis that have been done. Yeah, so it's a US-based company, and they provide a really cool tool. And I will show you an example that I have applied into my research. So once you log in to the model, you're gonna find this. You're gonna come up with this platform or this UI that you're gonna use, and then you have your credit here. At the beginning, they give you 1.3K credits, and for every run, it's like 200 credits. I think previously they said every credit is with $1. If you need more credit, you can buy it here and use it for your application. Yeah, for example, here, yeah, they gave me 1,300, and then every month they give you 10 credits. 10 credits basically doesn't run a lot of stuff, but for every research, it's gonna take like 200 credits, which is a lot of consumption, but it's like really useful. So what you're gonna do is that you're gonna drop your query here. Like it could be your research or the question that you want to answer. You want to find the research gaps in the literature, for example, and then you run your query here. I have an example that I have run, and I will test this tool more, but I have one example that I have run here. So the objective that I have asked the model to do, so you're going to have like this results, task, objective, and data sets if you have inputted data sets, because this model can also do analysis. So this was my question. I'm looking for research gaps in the application of generative artificial intelligence, for example, diffusion and gas, to solve reservoir history matching, building subsurface models of 2D demonstration, and what are the things that could be done fast and add a lot of value. And I gave example like it could be an alternative model or conditioning approaches. So this was my research objectives. And the model gave me a really nice report about 4 discoveries that could have been can be added in order to add a new to the literature or make progress toward the literature. And it comes with references. And I'm going to explain these references in a few. So for example, here we got direct generative posterior inference for reservoir history matching via likelihood gated diffusion. So this is like a very new approach that is usually used for image reconstruction, and they propose it for history matching. And then it gives like the background of the approach and some literature review that is relevant. So let's pick an example. Let's take these two as an example. So these are papers, and they are from ArchiveX. So you come here and you find like some papers that are not really related to subsurface, but are more related to computer science applications, but they could be useful for adding new stuff toward the literature. Because, for example, this paper was published in March 2025. So most likely this was not applied in the oil and gas. And if this is applied in the oil and gas, it could serve as a new tool or an additional tool that could help in solving like inverse problem. Another example. So this is unavailable. Let's see. Let's look into another example. Yeah. So this is University of Chile. Safe sampling for score-based model, classifier, and guided with conditional diffusion trajectory correction. And these are like mainly open source, but they are very useful to guide you to find approaches that could be useful for your practical application. All right. Now let's look at what did the model do. So you're gonna find here things like R1, R0, R42, R0 here, and also, yeah, R0 here, R37. So what are these? These are basically tasks. So if you look how the model ran, if we come to tasks, you will see that the model conducted 133 tasks. And the last task, this I have done it yesterday, the last task ended up at 214. So let's look when did the model start. So look how many tasks that have been performed from 11 to 2 p.m. So it took like 3 hours of work in order to generate this report, showing going through different literature and providing and looking what are the research gaps and going into deeper and deeper rabbit holes that could be useful. And the good thing is that you can access all of these tasks. So let's say, for example, what did it do at the beginning, like the first task. So you will come here and you will find all of these are references. So if we click on them, let's click on one of these. Yeah, so these are papers. And the model read the abstract, and then you can find things that are useful for doing the literature review that was conducted by the model. So these are all references that could be useful for if you are conducting literature review or you are trying to find research gaps. So the model from doing this task one, it went ahead and generated, let's say, task two. And for task two, it's going to be looking to some, like for example here, it generated this task, address the following research objective and research hypothesis. Research objective, find the example of physics-guided or physics-informed generative model where a physics-based loss is used for sampling GAN or VAE or diffusion model. So it's going to go ahead and find this. And once it finds this, it's going to also generate another task. And then you're going to move on to the next task. So this is the next task. Sometimes it's going to run several tasks in parallel, which is going to by doing one literature review, it can find different practical application and run parallel tasks at the same time to find what are the related things. So it's going to run for all of these models. So you will find, like, for example, this is a really new paper, con FILD. So let's look, maybe you can find it here. Yeah, this is the one, I think. No, not this one. 1.1. Yeah, so you're gonna find like very useful papers that could be applied to the research here. And then let's look. So here, for example, is changed to search for the literature on likelihood guided diffusion. So it's gonna keep going and improving the prompt and going through different rabbit hole until it answers the question that you're interested in. And then if you look to the results, you'll find the different ideas that could be useful for you. For example, the mesh agnostic generative representation of conditioning for cross-grid history matching, which is like a really still a problem that have not been solved yet, where you can build models that are independent of the grid size basically, and build models that where the grid could change. So, and then like you're gonna find here like papers. For example, this is going to be a paper that is related to how to apply this approach or the literature that is done here. And then we have geologically constrained generation via differentiable spatial statistics and composite physical guidance. And these are like really useful ideas that you can pursue. And the good thing here is that our question is that the gap could be, yeah, our question is that what are the things that could be done fast and add a lot of value? So these are the things that could be done fast and add a lot of value instantaneously in applying these different approaches. Yeah, so we basically have 4 discoveries here. And then if you want to go in details for each one of those, you can read, this is like the basic summary, and these are the tasks that allowed you to generate this topic. So if you click on them and you come here, you will find that where did this come from. So there is plenty of papers that have been used in order to generate this results. So for example, these are different papers that have been used. And you can also look into the reasoning. How did the model think about it? And how did it gather evidence and the data for every one of those tasks that we have been talking about. So this is like a really new model. So feel free to test it out and see how good it performs on your application. I found it really useful to generate new ideas and pursue research that could be impactful in the area of research that I'm conducting. Thank you.